Hey guys, it's Miss B, and I understand as you're doing your Why Cells Are Small lab that you're having some difficulty getting error bars to be individual error bars if you make a scatter plot. So what I want to tell you a workaround that I found that is a little clunky. It will not allow us to put a regression line, but we can definitely use this method to get the error bars that are individual on there that I want to see for statistical significance. Okay, so notice that what the problem's been before is if you were to take this information that has been that you've calculated, and what I did is I just made a little summary data table here. And one thing we need to do is we need to get the same level of significance for all of our values. And so notice what I did is I highlighted it and then I decreased it to where I didn't have any decimal places, and then I increased it to where I have one. And that'll give us all the same level of precision. So we need to do that first. Okay, notice that if what you probably were doing is going and making this scatter plot, and if you switch rows and columns, then you are able to put your individual data in, but that's not what we want because we don't want a bar chart, we want a scatter plot. So you have to go in, and if you were to change this to a scatter plot, then what ends up happening is, you either get them all in one line because you've got this weird thing here, and you get this you can get your trend line by going in and customizing and going to your series and getting your trend line. And you can, when you make this the power series, you get it really nice. And then you can say for the label, you can use the equation, you can show R squared, which shows that it's a really nice fit with this power series, showing it's this regression equation. Okay, so one thing that I want to do is I want to keep that because I do want to show this trend line, but I also need to be able to indicate those error bars to show the level of significance there. So here's what I'm going to do for this point. Okay, so I'm going to kind of drag this off somewhere so you can grab that one, and after you edit it and add your labels and such, you can go on. Okay, so what we need to do is I'm going to just take this side length in millimeters and I'm going to copy it, and I'm just going to put it below here because I need to try to make this a little different. Okay, so, and I want to go ahead and I'm going to put side length millimeters there. Okay, the next thing I'm going to do is I'm just going to repeat these values 5, 10, 20, and 30. Now I'm going to have to clean that up in terms of numerical values here. And I'm going to look and I'm just going to enter in this mean diffusion efficiency, and thankfully it's not very many points, just where it fits with that intersection. So this is at the 5 value, so I'm going to put 58. And then for the 10 value, I'm going to put 33.8. And for the 20, I'm going to put 18.1. You can kind of see what I'm doing here. I'm just making this a diagonal so that each one of these values becomes its own little series. So, and again, I'm going to highlight all this stuff, and I'm going to make sure that I've got one decimal place. And then I'm going to take all of this, and I'm going to highlight it, and I am going to make this a scatter plot. So I'm going to put insert my chart. Now it's going to look really weird initially, but I want to just go in and change it from the column chart. Now I'm going to change it to a scatter plot. And now I've got my graph. I've got 4 different colors, which I do want to kind of fix eventually. But initially, I'm good because now I can tell which point, this data series 1, I've got each value as a separate data series. So now when I customize it and I go to my series, I can add these error bars simply by changing the error bar to being a constant, and then just changing the value to 14, and then changing data series 2, changing its value to 10.3, and I'm going to go ahead as I do this and fix the color to be the same color as I go through each time. So if I go to, so I'm going to go back and fix that color. Okay, and so then when I go to data series 3, I'm going to make that error bar is going to be 6.1. I can change its color. And then I'll go to the last one, and I'm going to make that error bar 4.3. Okay, now let's see what I did here. It looks like this third one looks a little odd. So it looks like data series 3, the error bars are made percent, so I need to make that a constant. Okay, so now I've got my error bars that are listed. And all I really have to do at this point is now put my chart, I put my title. So the title, I probably want to title it whatever, an appropriate title, that effect of side length. And then go to my subtitle, and I can say that what the error bars represent. And then I can go horizontal axis size. That one's going to be the side length. Don't forget your units. I'm going to put my vertical axis title. I'm going to say that's going to be cell efficiency. And go scroll down through here, the vertical axis. Let's clean that up. The minimum value is 0, so that looks a little better. And then the only other thing I really want to do is when I look at my legend, I want to get rid of it because that looks odd. Okay, so that's the workaround. I know it's a little clunky. You can put one graph that shows the trend line and the other to show that you don't have overlapping error bars, at least between your highest and your lowest, so you can indicate your variability of data. So I hope that's helpful. Bring questions to class on Monday, and we'll look at more how we do this. Take care.